right, so question 9 is asking us to determine if the x value they give us is a critical number for f of x. And if it is, we have to tell them if it is a relative minimum or relative maximum, or it could be neither. So this is the function that I have, and here's the value that we want to check. Okay, so what is a critical value? Because they're asking us, decide if the given value of x is a critical number. Well, critical value happens, critical values are the x values that makes the first derivative equal to 0 or undefined. So for this function that is a polynomial, what we're going to do is we're going to find the first derivative, f of x, or f prime of x, using power rule. So I'm going to have 6x squared minus 6x minus 12. And you know what you can do is plug in. If you just want to check and see if this is a critical value, you can plug this in and see if it gives you 0. Okay? You know, that will be like answering this question. So I'll plug it in and see. So if I plug in 6 in here, a negative 1 into that first derivative, will it get me 0? I'll get a calculator. So 6 times negative 1 squared minus 6 times negative 1 minus 12. Sorry about all these extra mess that you don't need to see. So I plugged in negative 1 into the first derivative, and look, I got 0. Yay! So this is a critical value. Because the first derivative, because f prime of negative 1 is equal to 0, x equals negative 1 is a critical value, or critical number they said. I like to call it critical value of, or for, critical value for f. Okay, so did I answer the question completely? No, probably not think so. So it said, if so, decide whether the point is a relative minimum, relative maximum, or neither. I'm going to use the second derivative test to confirm that. Okay, so take the second derivative. Find f double prime of x by taking the derivative of the first derivative. Okay, so I'm going to have 12x minus 6. And what we're going to do is plug in that x equals negative 1 into the second derivative. And we will look at the sign of this. I'm doing 12 times negative 1 minus 6. When I plug in that critical value into the second derivative, I get negative 18, which is a negative number. Well, because f double prime of negative 1 is less than 0, x equals negative 1 is where relative max happens. Okay, that is the second derivative test. If the second derivative comes out to be positive, then I would have concluded that x equals negative 1 is where relative minimum happens. But if the second derivative is less than 0, if it's negative, then concludes that it is where the relative maximum happens. I don't think this problem asked me to find the relative max. We can easily plug in this x value into the original function to write it as a point in an ordered pair. But I think I'm going to stop this right here. And if you guys stop here, then, you know, that will be perfectly fine for the exam problem. And of course, you know, guys, there are different ways to do this, but this is just one way that I saw. Because if they ask me for a critical value, we know critical value is the x value that makes the first derivative equal to 0. So it made sense for me to just find the first derivative, plug it in, and see if it comes out to be 0. Now look, if it doesn't come out to be 0, then you can conclude, hey, it's not a critical value. If it's not a critical value, it's not going to be a relative minimum or relative maximum. So you can just say it is not a critical value, and this blue part, you can skip it. okay? But if it is critical value, then you have to support it somehow. Show me some work. Either it could be the second derivative test that I did, or you can do a first derivative test sign work to the left and right of that critical value to show me if it's the relative minimum or maximum, okay?